I'm Bhanuka Devansa, and the topic I'm presenting on will be cryosurgery and surgical lasers. Initially, we'll look into cryosurgery. So, cryosurgery is simply the selective exposure of tissues to extreme cold and hence causing the destruction or elimination of abnormal or malignant cells. So, this is a minimal invasive surgical procedure. So, some might call it a non-invasive surgical procedure as well, but it actually depends on the type of application we're using it for. So, we talk about the medical background of cryosurgery. So, here we have demonstrated the bioheat equation. So the Penn's bioheat transfer model can actually be used to evaluate the phenomena of heat transfer through conduction, convection, or metabolism when it comes to the bioheat transfer. So here we can look at the cells before treatment and after treatment using cryosurgery. So we can see that you see that there's the ice crystal formation, and then the thermal shock actually, which has caused the cell membrane to fail and permanently leading to cell death. So here we have the mechanisms of cell destruction. So there's immediate cell destruction and delayed cell destruction. And then we have cell destruction by freezing. So there's extracellular ice crystallization and intracellular ice crystallization. So here, this is what actually we are seeing. So the ice crystal formation actually happens from intercellular and extracellular fluid, resulting in freezing and causing physical disruption of the cell. So if you talk about the physical principle of operation in cryosurgery, simply there's the rapid freezing and slow thawing, and then the repetition. So because if you talk about the cooling, we have to cool the so basically there's 5 control factors in cryosurgery. That's the cooling rate, temperature, thawing rate, the freeze duration, and the repetitive freeze thaw cycle. So the freezing actually needs to happen to say minus 50 degrees Celsius or below, and then the thawing rate is actually very important because is the prime destructive factor, and it should be slow as possible. And then we have to keep on continuing this repetitive freeze thaw cycle to make sure that all the required malignant cells are destroyed. So if you talk about the cryogen, so there's multiple cryogens that's actually available. So we have used liquid nitrogen, which has the lowest boiling point, which is minus 196 degrees Celsius. And then we have argon, which has minus 186 degrees Celsius. Liquid nitrogen is actually the most commonly used cryogen when it comes to cryosurgery. Then we have 7 techniques here list down which are used in cryosurgery, but these can actually be confined to a closed system with the use of a probe, and an open system with the use of a liquid nitrogen spray or cotton tip. So that's actually the 7 techniques that we have shown here. So actually here we can see the tweezers. So we have Teflon, frozen Teflon tweezers being used to remove a malignant cell and like a tissue package. So if not, you can use a dipstick or sort of like a cotton swab dipped in liquid nitrogen and then applying the cryogen on top of the the malignant tissue formation. And then we can actually use the open spray technique, which is actually the most commonly used technique when it comes to cryosurgery operations. We actually spray the cryogen on top of the lesion. If not, we can use the semi-open spray, which we actually have to localize the spray into a cone and then direct it towards the lesion. And then we have the closed techniques, which is first we have the semi-closed technique where the you see the metal cone is used to keep inject the cryogen on top of the lesion by placing it tightly on the skin. And then we have the closed probe contact or the cryo probe, where we actually deliver the cryogen via a closed loop. So and here you can see, and here actually in the closed loop there's ice ball formation, and in the ice ball formation you can see that the temperature close to the lesion is very low, close to minus 60 degrees Celsius, and as you move forward in the ice ball, it actually reduces. So when it comes to the cryoprobe, we actually use a Joule-Thomson effect. So Joule-Thomson effect basically states is that when we move the gas from high pressure to a low pressure, so this high pressure, this low pressure, there's a reduction of temperature causing an ice ball. So basically that's what happens in the cryoprobe. So one of the most prominent examples for commercially available cryosurgical device is the cryoprobe. So you can see here it's like, so it has a handheld device. It has the ergonomic shape of like a pen. So it has so it has N2O as its cryogen. So a cold nitrous oxide gas. So it's actually like a closed loop system which we actually use on the lesion. And then we have different micro applicators, which we have shown here. So ranging from 1 millimeter to 8 millimeter. So based on the type of lesion we are trying to treat, we can actually use certain types of cryoprobes. So ranging from 1 millimeter to 8 millimeter accuracy. So if you talk about the safety standards used in cryoprobes, so the cryoprobe's degree of protection against electrical hazards complies with the IEC IP20, and also if you talk about if the FDA is like registered under section 878.435 knot on the cryosurgical unit and accessories. So apart from that, we have some general procedures, safety procedures that need to be followed when you are using the cryosurgical cryoprobe. So these can actually be summarized as like handling the instrument and the liquid nitrogen properly, wearing proper PP, and having enough ventilation when you're using it. So next, we can talk about surgical lasers, which can actually be considered as a pole opposite of cryosurgery in terms of application. So laser surgery is actually like a type of surgery that uses special light beams instead of instruments for surgical procedures. So laser actually stands for light amplification by the simulated emission of radiation. So here actually what happens is like the laser serves as a source of radiant power, which is directed towards the tissue, and then actually it increases the temperature of the tissue like by destroys it. So basically application of laser in the surgical context can be like summarized as the shrink and destroy of tumors to help prevent blood loss by sealing small blood vessels, refractive eye surgery, or we call this LASIK eye surgery, and dental procedures, and also in dermatology to remove warts, birthmarks, acne, etc. Right. So basically, laser surgery involves three separate applications. That's photocoagulation, photovaporization, photoablation. So in photocoagulation, the laser actually induces heat from 50 degrees Celsius to 100 degrees Celsius and dissolves the proteins and in the biomolecules. These actually examples for photocoagulation is like diabetic retinopathy treatments, removing of tumors, and also bloodless incisions. And then we have the photovaporization. This is when we actually increase the temperature above 100 degrees Celsius. It actually, so basically tissues are consisting of 70% water, and once you like it starts boiling, it actually evaporates all the water and sort of vaporizes the tissue, causing the tissue to be completely destroyed. So this is photovaporization. And photoablation is when actually we are using high power lasers in the ultraviolet wavelength. The chemical bonds are broken without causing local heating. So this is actually what happens in photoablation. So here we actually have the instrumentation aspect of the surgical laser furthermore. So basically the surgical laser is a device capable of generating electromagnetic energy in the ultraviolet, visible, and infrared regions of the spectrum. So based on the type of the tissue that we're trying to target, we can use the required laser and the required wavelength. So basically the beam energy is controlled by either an electron shutter or set by the operator, or like the operator control with the put pedal that can be decided by the operator. So lasers can be generally categorized as like gas lasers, fluid lasers, diode lasers, and solid state lasers based on the type of medium that's being used. And also apart from the medium, we can also like vary the medium once again, and we can get different types of laser outputs. So here we have the carbon dioxide laser, argon laser, etc. So based on the application, once again, we can use the required laser. And then the excimer laser has been focused here because that's the laser type that we're going to focus on commercially. So excimer laser is like as an ultraviolet laser. So the excimer gain medium is like a gas mixture typically containing a noble gas and a halogen. So here we can see these are all combinations of noble gas and halogen. So this type of lasers, the excimer laser is commonly used for LASIK surgery. Right. So the star S4 IR excimer laser is one of the most commonly used, or like the most prominent excimer lasers that's being used. This is used for LASIK surgery, where we actually try to treat the myopia, hyperopia, and mixed astigmatism. So basically, short-sightedness, long-sightedness, we will be treated using the star S4 IR laser. So this is manufactured by Ammo Manufacturing USA. So the IEC standards of the star S4 IR laser are demonstrated here. So it has the IEC 60825I standard, one standard. So basically it follows all the laser related standards given by the IEC that has been mentioned here. And also it is FDA approval has been obtained using the given shown details. So basically it follows all the FDA and IEC standard that has been mentioned here. So basically, if you talk about the conclusion, cryosurgery and laser surgery are both effective alternatives for invasive surgical methods. So it can be considered as a minimal invasive or even non-invasive surgical technique. based on the application that we're using it. So it actually depends on whatever the type of application that we're going to use it for. So basically, if you talk about the type of surgical method that we're going to use is obviously going to be decided based on the type of malignant tissue or surgery type that we are going to go for. That's basically it for with my presentation. Thank you.